In our consciousness, there are some common security misconceptions, such as no one is interested in my network, no one will hack my network, I've never been hacked, right? The IT department takes these matters to heart. I have a firewall, no worries, right? You say no one is interested in your network, which might mean it's not valuable. Anything of value will definitely be targeted. Someone will surely be concerned. So you can't have that mindset, right? You say there's nothing of value at home. We started up and it's fine, right? You leave the door open. Even if there's nothing of value at home, someone might just come in to grab a roll of toilet paper, right? So we shouldn't think that no one is interested in your network. I've never been hacked, but that's just because either they think it's just not worth it. Some people think it's not worth the effort, or perhaps you just haven't encountered it yet. Because this stuff, cybersecurity, is somewhat mystic, because we also don't know exactly why hackers do what they do, right? Even some people, they are just interested in messing with networks, right? They go and stir up some activity completely because, why? It's just because they say, I just want to prove myself. Like, there was a virus called Panda burning incense. Everyone knows. This thing, its developer just did it for fun, right? He just wanted to prove himself, to show off. And then he created such a thing. So don't think that no one is interested in you. Some people, they say, I just want to prove myself. And these kinds are honestly, especially hard to guard against because there's no logic to it. Like in real life, like when the police handle cases, criminal investigations, if some heinous crime happens like murder, etc., they're not afraid of interest conflicts, revenge killings, crimes of passion, etc. What they really fear is someone with a mental issue, for example. Someone, he says his grandmother, he said at his grandfather's funeral he saw a pretty girl. But then he couldn't contact her anymore, so what does he do? He kills his grandmother, then holds another funeral. Honestly, it's these kinds of situations that investigators fear the most. We in security also fear this kind of baseless attacks, right? So honestly, we shouldn't think that no one is interested in our network, or think that I've never been hacked, or that only nice people listen to us, honestly with us. We don't need to think about this, right? Because we're the IT department. Overall, it's often a lack of security awareness that leads to not prioritizing network security. If a company doesn't prioritize network security, especially in a city like Ningde, it's easy to run into problems due to a lack of budget. With no budget, a good housewife can't cook without rice, right? You say, in your company, if there isn't even a firewall, then you're entirely reliant on technical defenses, which is very hard to maintain. So, we must first have this security awareness. Then we can do what? Mitigate attacks. Mitigation, in this sense, involves using targeted technologies for comprehensive defense. We have to defend against these dangers. We need to think from the perspective of an attacker. If I were a bad guy, how would I handle this? How would I do it? By doing so, we can target our defenses to defend, because these security attacks are varied. Honestly, if you completely think from a defender's perspective, it's very likely that there will always be some misconceptions. Here, next, it's like this. We, based on our network's needs, look at, for example, based on privacy, integrity, availability. How do we defend against attacks? Of course, there's almost no absolute defense. We usually, what do? We mitigate. Okay, then next, threat defense technologies, black magic defense. Here, usually, right, we need to defend against this black magic. We need some tools like firewalls, IPS, some content security devices. Why do we mention these examples? Because these are network devices, our network engineers, our tools, or our network engineers' tools, our network engineers' devices, managed by our network engineers. The first one is a firewall, which works like this. It's its function. Why is it called a wall? Because it blocks the network, or isolates it. The firewall, it isolates the network into multiple areas. It's just like that. The firewall is used to isolate network areas. So, why do we use firewalls to isolate? Because we have some traffic that we still want to allow to communicate. If you say you don't want any of your traffic to communicate, then you might as well not connect your network cables at all, right? Because we have some traffic that needs to interact between two areas, but we need to stop other traffic from interacting. Then at that time, we need such a device, a firewall. First of all, it must be able to defend itself against attacks, right? You say, honestly, right? It's just honestly, if your firewall can't defend itself against attacks, then someone just needs to take it down, and that's it, right? So the first point is, it must be able to defend itself, resist attacks. Then, we deploy it on the critical path of traffic to use it to isolate between areas. Such devices typically are usually used for this purpose. Its primary strategy is to deny. That is to say, unless we explicitly allow certain traffic, other traffic is typically denied. So, we which traffic want to be able to pass through the firewall. In that case, we need to set specific policies on the firewall. Such devices, meaning firewalls, can be summarized in one sentence: firewall. Firewall interfaces connect to different zones. These zones, we can call them secure zones. Then based on what? Based on policies to manage traffic control. Just based on policies to manage traffic control. Of course, this traffic control is also access control. Firewall interfaces are definitely connected to different secure zones. That is the firewall. Firewall isolates zones. Zones, in this place, the firewall is used to isolate zones. It's unlike our usual routers and switches which do access control at the interface level. Firewall policies are implemented between zones. This means its feature is to say it controls traffic between zones. And this thing is the firewall. It is currently this most typical security device, generally speaking, right? When talking about network security, the first thing that comes to mind is definitely the firewall. So about the firewall, like say this topology tree. In this topology tree, there's a firewall. And on the left side, you see a bunch of computers, should be the internal network. And on the outside, there's a cloud, which might be the external network, right? On the opposite side of the internet, there will be other hosts. And at that time, we can selectively allow some of the traffic to pass through the firewall. At that time, which traffic can pass through the firewall and which cannot is determined by the policies on the firewall. So on this side, we mean that we can use the firewall to isolate the network into multiple zones and then control the interactions between these zones. Next, IPS, which stands for Intrusion Prevention System or Intrusion Detection System. This device actually is very similar to our antivirus software. We install an antivirus on our computer, and the antivirus usually works based on what? Based on a virus database, right? It operates based on a virus database. Actually, antivirus software has two main components. One is the engine, one is the antivirus engine, and the other is the virus database. The antivirus engine can generally, nowadays, antivirus software available in the market is of course some antivirus software claims to be free. Current antivirus software on the market has an antivirus engine. And this antivirus engine has an antivirus engine, and it's not necessarily just one engine. This engine, it will go to monitor our system. For instance, it will judge based on the behavior of some software. Of course, you can have it scan our system, it has an engine. Then, additionally, it also needs to have a virus database, which is akin to the antivirus engine is like the police. And the virus database is like a warrant. The police can, based on the police, right? See someone acting suspiciously, they might need to go to monitor. So this means the antivirus engine, similar to the police, and the virus database is similar to a warrant. So what does that mean? The police, right? They have a warrant. And if they see someone who looks just like someone on the warrant, right? They definitely have to stop them, just to ask. So this means the virus database records the characteristics of some viruses. This is antivirus software, and our IPS then acts similarly, using the antivirus engine and the virus database to identify and block threats. Thus, IPS not only monitors, but actively prevents intrusions by blocking harmful traffic based on its threat database. It's like this. IPS can be thought of as a network version of antivirus software. essentially embedding an antivirus solution inside a box. This box is essentially strung into our network. When packets pass through this IPS, it performs a deep inspection based on a characteristic library. So, IPS is similar to antivirus software in that it has its own engine and its own characteristic library. This library is based on packet data. That is, at this time, it can inspect these packets to identify suspicious code. In this regard, it needs to scan these packets to recognize, and then it can undertake defensive actions. This device can act as a complement to firewalls. Why is this? Normally, IPS is typically deployed inside the firewall, not outside, because think about it. Is it easier to filter based on address and port, or why think about it? To filter based on the characteristics within the packet. It's easier or based on the packet's characteristics. Clearly, right? Filtering based on address and port is a bit easier. At this time, similarly, right, just like say in the restroom, right, like for example, the restroom, right, like male and female bathrooms, it's simple, right? We don't consider those things like Walmart shopping bags or armed helicopters and their genders. Just usually, it's either male or female. In this case, it's easier to distinguish, but you say, right, you need to look at what's this person's name, where they are from, like where they work or study, and other personal details. You need to, or say you judge based on how this person looks or based on their appearance. Using these features to identify is easier. Clearly, firewalls make it somewhat easier. Of course, in today's next generation firewalls, they might integrate this IPS also within the same device. Why? It's because many security devices now are integrated into a single box. And the advantage of putting it in one box is that it might be more efficient. But traditionally speaking, a firewall is one type of device and IPS is another. It can act as a supplement to the firewall. You see, the firewall can filter out some traffic. And for the remaining traffic, whether there's any trickery inside, IPS can perform further inspections. If you place it outside the firewall, frankly, IPS would be under a lot of pressure. That is, right, you say, right, it would make it a lot more stressful. So IPS is like a network version of antivirus software. It's like antivirus software, that is IPS. IPS has its own engine and its own characteristic library. These two components are very similar. One is installed in our system and the other is on the network. Of course, can your company's computers go without antivirus software, relying solely on IPS? Honestly speaking, that's not how it works. From the perspective of efficiency, antivirus software is more efficient. Why? Our data packets involve something called fragmentation, right? You have to identify from fragmented packets. Is it easy? Isn't it? But you say, local antivirus software has the whole file to let you do the detection. Which one do you think is easier? Which one is more efficient? Certainly, antivirus software is more efficient, so IPS can act as a supplementary security measure. We can deploy it within the network. That means, IPS it has this thing, but when you design a security architecture, don't think of relying solely on it to solve malware issues. This is IPS. Next, we have content security appliances, which usually target specific applications. This means they provide finely tuned protection for specific applications. For instance, such as Cisco's product called ESA, which is for Email Security Device. Email Security Appliance Device Email Security Appearance. Another model, the WSA, Web Security Appliance, is specifically for web security. From the name, you know that ESA only handles email, right? Only email security. And WSA, it only handles web security. At this point, these specific products, security products, typically specialize deeply in one area. They do so very meticulously. They can target specific aspects like email security or web security to filter and manage content. Not just limited to URLs and some content information. Here you say it can comprehensively protect against specific applications. It provides finely tuned security measures. So one thing is, when you scan any device, when you scan packets, the deeper you go, the more performance it consumes. That is to say, either you target specific services or applications for deep scanning like these content security devices, or you say like firewalls, right? You guard almost all data with a rough protective control. Do a rough control, right? Like that, an IPS, right? IPS 2, it is also in a specific way you could consider it based on specific applications. It's also specific. Why? Because IPS, it has its own characteristics, right? It has its own characteristic library. It mainly relies on this, mainly based on the characteristic library from its engine. Honestly speaking, right, the efficiency isn't very high. It's akin to what? If a police officer doesn't have a warrant and he has to catch a fugitive, the efficiency definitely won't be high. Even if he goes to a Jackie Chun concert, right? He still needs to know the fugitive's characteristics. So, thus, our devices, the performance of our devices, actually, about the performance of devices, you say it's just this much. So our security products have different classifications because our essentially network devices like routers, switches, firewalls, including these things like IPS, ESA, WSA, they are fundamentally computers. Or you could say they are all servers, with routers serving as network service servers, right? Firewalls provide network security services, if you think about it that way. They are essentially computers, each with their own chips, such as CPU-like chips, their own memory, their own storage devices such as flash cards, solid-state drives, etc. Or hard drives. These components, so these various network devices, are developed for different needs. Our different devices are deployed at different locations within the network. ESA, for example, primarily protects emails, meaning it provides security for emails. Like when an email comes from outside, at that time ESA can scan it. And if the email contains malicious information, what then? Directly eliminate it. But if, the email is normal, then in that case, the email will of course be routed normally to the internal network. Of course, as for how it gets to it, or how it acts as a proxy, in that case, you say, this thing, from a functional perspective, ESA, this product is used for filtering emails, and WSA, it's used for filtering, It provides web protection. So in this case, it can control access, it can manage which sites our internal hosts can visit and which they cannot, So at this time, it's like this. We access sites. Honestly, not all are safe on our internet. There are many malicious sites, and for some users who are unaware, our WSA can prevent them from accessing these sites. Or say from a company policy perspective, we can block users from visiting certain sites during work hours, like gaming or financial sites. And other such sites, we can set these restrictions, such as online shopping sites, These can be restricted, so in this case, WSA, it actually serves as a proxy, meaning it acts as a proxy server. Why a proxy, Well, you say some firewalls can also perform some web-based filtering, like some firewalls can perform URL filtering, among others. But one point is that they don't match up to WSA. WSA can act as a proxy server, essentially allowing many internal hosts to access the same network resources. WSA can provide caching, because our network has many hosts accessing the same web content, which is actually the same, very likely, like news, you say that, Some people, many people, they just go to check the news, see the latest updates, those things. Once one person has seen them, they will store them in the cache, and subsequent people can directly read from the cache, not consuming internet bandwidth, which is another benefit, helping us to save on internet bandwidth. And on the other hand, it can deploy web security. So WSA is also a quite distinctive product. WSA does web defense. ESA does email defense. In this case, they are security products targeting specific applications. They belong to content security devices. Let's take a short break now, shall we? We'll continue later. All right? After the break, we will delve further into how these content security devices function and discuss their roles in more detail within our network security architecture. So let's pause here, and when we return, we'll explore additional features and settings of these security devices.